Time of starting. Ask whether you want to go to school.
So next session may get extended, but it's very useful session. You can practice all the Tensorflow commands. It's very. Hi, good evening, sir.
Hello. Good
Yeah,
evening. Good evening,
we
sir.
welcome you for this session on Tensorflow and Keras. And the participants are getting ready with their Jupyter Lab notebooks.
Okay.
Is it working? So in the machine already we have installed OpenCV, TensorFlow, Keras, and PyTorch. If you have any notebooks, please share it to the audience, sir, so that.
Okay. I just want to know which slide you are able to see. Which.
It's the first slide, sir.
Okay, the slide, right? Okay.
Yes,
Nice.
yes. It's visible.
Okay. So do we start?
Yes, sir. We can start.
Okay. Great. So first of all, I would like to thank Balaji sir for having me here and for having another session on this. Today's agenda is about I will be using two data sets. One is fashion amnesty data set and one is American Sign Language data set. We are going to understand what they mean and then we will make neural networks using them, and we will also understand what is the purpose of those data set. We will try to improve the performance of our neural network model. Right? I hope the agenda is clear to everyone. So shall we start with the code? I hope you are all ready with your Jupyter notebooks. They have started. So
Sir, can you please keep your mic closer?
okay.
I'll test away.
Is it better?
Yeah. Is it audible? Better?
Is it better? Is it better?
Yeah, it's now better. Now better.
Okay. Okay. So right. So let us begin with this. Okay. So first of all, we need to understand what is MNIST, right? On the data set that we are going to work on. So let me just Google it out for you. Okay. I hope you can see my slides, my browser, or not? Yes. Okay, so amnest data is set is the is a handwritten images, right? Handwritten numbers. Okay, you see. Now let me just go to the Wikipedia page. If you can see this image, right? So this is the data set for handwritten images. These are numbers, right, which are handwritten, and we have a given image on which a number is written using your hands, and we have a category for it, which is the corresponding number. digits. Right? So we have is we have this particular image. We have one image and a label corresponding to this image. Every image will have a corresponding label, right? So we are going to first of all get the MNIST dataset, because MNIST dataset is hello. Are you disconnected? Hello. Are you disconnected or still? Hello. Hello.
Sir?
Yeah. I am not able to see you. Or are you there? Right. Please make me the presenter.
Yes. Okay.
Okay. Now I am again sharing my. I will be sharing my
Okay.
full screen. Okay. So
Okay.
that there is no confusion.
So you can share your screen.
Yeah. Is it shared?
Yes.
Yeah. Okay. Nice. So MNIST is an important data set, and it is usually used for training purposes for teaching neural networks, and that is why MNIST is already inbuilt in the Keras module, Keras library, and inside datasets module, right? So what you need to do is you need to import MNIST from Keras datasets. So you write from Keras datasets import MNIST. Okay. So once you do this, there will be no output. If there is no output, it means it has done properly. It is done, no issues. If you are facing issues with your version of Python kernel or your version of Keras, you can try it out on Google Colab. So now this is what? Now we have to load the MNIST data. So the data has to be loaded into two parts, training and validation, right? First, let me tell you what is training and what is validation.
Just zoom in the text, sir.
Yeah, I will do that. Is it okay?
Is it okay?
Yeah. So what we need to do is we have a data set, right? I hope you are able to see my this text editor, you know,
Yes.
data set, and there are two parts of it, right? Training, training set and test set, right? So what is the purpose of training set is to learn, right? to give examples to the model to learn, right? And test set is all about finding if our model has learned or not, or you can say how much has our model learned, right? So this is, you can understand this as the syllabus uh, for studying, right? And this is the examination that you can think of, right? You can say it as a practice test, right? Or exam, whatever, right? And one thing that is important is to use new questions, right? You need to have new questions in the exam or in the test set. The same questions which was in the syllabus, if you give the same questions in the testing phase, then the student will be able to answer easily, right? So if you want to find out if the student has learned something or not, he has not just memorized it, then you need to have new questions, right? And that is the purpose we split the data set, into two, right? We also do it, sometimes we split it into three, right? And that is called train set, validation set, and test set, right? So this is done when you want to train multiple times, right? And trying to improve the performance of the model, right? So for now, what we are going to do, for now we are only taking into account this two, right? We are going to train it and then we are going to test it, that's it, right? So we have to take two parts of training and validation. You can use test also, you can use validation also, right? Okay, so amnist dot load data we have to use, and this will populate our x train, y train, x valid, y valid. Now what these x train, y train, x valid, y valid, they will be numpy nd arrays. So let us run this one and then let us see what do we get. So it downloads some data and then populates x train. Let us see what is an x train. So x train is an array, right? If you want to see the type of x train, you can use type of x train. It will give you whatever the type, numpy nd array, right? If you want to find the shape of x train, so you will write shape x underscore train. Oh sorry, x train dot shape, right? It is 60,000, 28, 28. As I have already given you a hint, right, that these are images. So what do we infer from this? So we are seeing that this is the x train has a shape of 60,000 by 28 by 28. It is a three-dimensional numpy array, right? So what is the shape of x train? 60,000 by 28 by 28. What does this mean? Please try to find out the answer. Let me proceed and I want you to answer me. Okay. And then we also see what is y train. So y train are again numbers, right? 5, 0, 4, something like this. And all the data types, they are integers, 2 int 8, 8 bit integers. if we see the one value, one element inside xtrain, if we
Sir,
see,
please go to the previous cell. Participants are coming very slowly. They
okay,
want to see that third one. Third one.
sorry, this
Second one.
Second one. Okay.
this one. I am putting this link to you. How to chat. And also to you. Sorry, I am new to this WebEx. We don't use it usually, so possible that
Can you please send it by mail? That
yes,
link.
yes. I will mail you. I am replying to this mail only. Okay, so it will be easy.
Okay. Okay.
I'm just sending without writing anything.
Okay.
Okay.
Yeah, got it, sir.
Okay, nice. So we have x thread, y thread, x valid, y valid, which is loaded from mnist.loaded. Right. Now let us see what xtrain is. Xtrain is a three-dimensional numpy array, right? And I just want to see what is the one value inside xtrain, right? Xtrain 0. Xtrain 0 contains how many of them are there? 1, 2, 3, 4, 5, 6. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 26, and there are 28 zeros. Okay, so there are 28 zeros. So 28, 28, and like this, all 28, and there are some numbers also available somewhere, right? Not everywhere, but somewhere numbers are available, right? So the maximum number that we can see here is up to here, it is 253, right? 253 is the maximum till now, you know. We have not seen anything more than 253, right? 253 is the maximum till now.
Any doubt, you call me. I will stop it.
Yes, if there is any doubt, please stop me. Please tell Balaji sir and he will tell me to stop and we will discuss. Okay, so these are numbers, right? You see that these numbers are 8-bit numbers, right? 8-bit integers, and there are 28 such numbers, right? So let me see the shape of x trade. The shape of x trade is 28 by 28. So there are 28 such arrays inside this. Okay, right? So you see that the numbers are from 0 to 253, right? Because it is an 8-bit integer. 8-bit integer means the numbers can be between, it is unsigned int 8, right? U int 8, which means that the numbers will be between 0 to 255, not more than that. because there is no space for more numbers. Okay, so I
Then
would like,
receive.
yeah, any question? Is there any question or is it all good? Okay. So I am just now trying to plot it, right? And we have a module that we have discussed, matplotlib.pyplot, and now I am plotting that. I see that it is an I plot that xtrain 0, the first element of the xtrain numpy nd array, as an image, right? And I make the color map. CMap is the color map. CMap as gray. It means 0 will be black and 1 and like 255 will be white. Okay. So this is what I get. Do you know what is this? This is number 5, isn't it? It is a 28 by 28 matrix, and the way it is, the number is 5. It is also evident here, but here it is not visible because the output is compressed into made into multiple lines. So some values are 0, most of them are 0, and some are numbers, right? Non-zero numbers. And when we are going to plot it, we get this. Okay, this is the number 5, handwritten number 5. Okay, now let us see what is the corresponding y value. The corresponding y value is also 5, right? Now you see what is that, what is it? Let me write it here. X train 5, right? And y train 5, right? So this one is the image, and then this one is the digit. Okay, this is the image and this is the digit. Okay, x train I is a is an is a let me write it. It is a 2D array, right? X train I is a 2D array, and then y train I is uh, it is a number, right? It's a number. So do you see the mapping between them? Image and the number. This is how the MNIST dataset is made. It is in this particular format. Okay. So similarly you see the x valid shape. So I have divided two parts, x train and x valid. Now this x valid is 10,000. How many images are there? There are 10,000 images, right? And the size of each image is 28 by 28. Okay, does it make sense? Now we have studied about reshaping. Okay, so how many total samples are there? Total data set size is there 70,000, 60,000 extra, 10,000 x valid. So now total are 70,000 images are there. Okay. Right. So I hope you have studied the basics of neural networks, right? Have you studied? If not, then I will give you. Yes, yes. Okay, so
Yes.
okay, great. So you see that the first layer, right? First layer, right? It it has suppose it has it has to be the size of input, right? the the size of the first layer has to be the size of input, size of input, or size of one data point, right? What is one data point in this case? One image, which is 28 by 28, right? So that is why we reshape this whole X train into 60,000, which is already the case, into 784. 784, why? Because
If I get it out, please ask me, I will come.
28 times 28 is equal to 784. Okay, that is why we are going to uh, com- compress the 28 by 28 image. I mean, you cannot say compress, you should say I mean flatten it, 28 by 28 image in two dimensional array into one dimensional array, so that we can give it to the neural network. Okay, so similarly here also, so we are going to reshape X state and X valid. Okay, is there any question? Okay,
Yes, yes. That's what you're just telling what is the
okay, so now we have reshaped the data set. What is the why do we need to reshape? Why do we need to reshape? We need to reshape because we need to transform our data set, data points, into a format which can be directly given to the neural network, right? So the actually the first if you see here, right? Yeah, if you see here, this is one dimensional. This input is, this is one dimensional, and one data point is 28 by 28. You need to convert it into one dimension. That is why we have done the reshaping. Okay, so now when you have reshaped the data, the input data, right, you normalize it, right? Because the values are from 0 to 255, right? So in order to normalize, you divide it by the maximum number, right? So you are normalizing it. Okay, makes sense. You normalize it because you don't want, you want the overall system, the neural network, to converge quickly, to quickly go to the global minima of error, of the loss, right? That is why it is better to normalize, so that you play with lesser number of values, less amount of values than with very high values. Okay, that is why it is better to normalize. Okay. After reshaping and then normalizing, our X and Y data is ready. So let us have a look at X train, right? So okay, it is not visible. I will just see 0, right? So now it is converted, right? Okay, so now how many categories are there? 10, 0 to 9 digits are there. So num categories, I have just taken a variable called num categories and I have made it, initialize it with 10. This white train is not, we have already seen white train, right? Now this data set is categorical, okay? This white train is categorical, but here they are numbers, right? So do you know the difference between categorical and categorical versus numerical data? What is the difference between categorical and numerical data, right? So in categorical data, there is no less than or greater than relation, right? It means if 1 and 2 are categories, 1 is not less than 2. Is it okay? Is it clear? There is no such relationship which says 1 is less than 2, greater than 2. This is because they are now, in this particular example, they are categories, right? They are not numbers as such. Okay? For categorical data, we use classification. This is a classification problem. And for numerical data, we use regression, right? And regression, numerical data. Okay. Now that is why we need to convert this white range, because it is presently an integer. Integer is a number. It is presently in the integer, you assign integer format. It is a number. Right now it is numerical, but actually its meaning is categorical. Right? So you need to convert this to categorical. For that, there is already a module inside Tensorflow, right? Tensorflow.keras.utils import to categorical. So you need to import this particular thing, and then you need to transform white rain into a categorical kind of data, right? This has to be, you also need to provide how many categories are there, right? So here you have written num categories is equal to 10, and here and now white rain num categories. So what it will do, so now after this white rain it has become two-dimensional. Okay, now white rain has become two-dimensional. What has happened? Can anyone answer? Can anyone explain what has happened? Why has a two-dimensional, one-dimensional data become two-dimensional when we have converted into categories? Anyone would like to answer? Okay.
Please be louder.
One hot encoding.
Excellent. Who said? That is the right answer. Perfect. 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 Sorry. What is your name?
Suresh.
Suresh sir. Thank you. Thank you very much. You are absolutely right. It does one hot encoding. And now why do we need to do one hot encoding? And what does one hot encoding mean? Let us have a look at it. One hot encoding is suppose gender, right, is an example. It is male or it is female, right? So this is categorical, right? So but this as a column, if you take gender as a column, right, it will have multiple values, right? So with one hot encoding, you write gender male. There are now two columns, gender male and gender female, right? So it will be 1, and then this will be 0 for some cases. Some cases this will be 0, this will be 1, right? Because the first initially this the first row was male, so male is 1 and then female is 0. The second row was female, so gender male is 0 and female is 1. It says belongingness to a particular category, right? So now we see here white train. We have seen some zeros and ones are written. Now let me white train 0. I'm just trying to find out one. This one. This is 0, 1, 2, 3, 4, 5. If you remember what was x train 0, then you must see that it is number 5. Okay, sorry. When you plotted it, I have plotted it here. So x train 0 was number 5. Okay, and y train 0 was 5. So you see at the place of 5 it is coming 1, right? This is 0, 0, 1, 2, 3, 4 and 5. At the place of 5 it is coming 1, right? Okay. So now let us do the same thing with the y valid, right? Because for testing also you need to do the same kind of transformations, right? And again y valid will also be similar. Now we are going to do the next step. We are going to build a neural network for this. Okay, so for building a neural network, what we are going to do is that we are going to import some libraries from Tensorflow Keras. So from Tensorflow Keras models we are going to import sequential, right? Okay, and then we are going to import dense. So a model, the constructor for creating a neural network model is sequential, right? And to make a dense layer, right? A fully connected layer. So let me write here sequential for creating a neural network and dense for a fully connected layer, right? Dense is for a fully connected layer. Okay, so we initialize the model. I am just using the variable model equal to sequential. This will create a model object. Okay, this is going to create a model object, and after you create this object, then into this you are going to add layers, right? This you will do model summary because it has not been built. It will not be there. So now I have given this model dot add. Let me write it here. So model dot add. This add, what will it do? This will add a new layer over the last layer of the model. Okay, so once you do add, you cannot remove that layer. You again have to create the new model. You have to delete the model and again create the new model. Okay, and then we have dense, right? Dense is for creating a fully connected layer. You can have other kinds of layer as well. When you will see the convolutional neural networks, you will be seeing it today also. So there you can make different types of layers. So, and then units is units is the number of neurons. Okay, and then activation is the activation function, right? Makes sense. So which you want TANAG, you want ReLU, whichever activation function you want, you can specify here, right? Activation functions are, if you, it if you are starting, if you are creating your own new activation function, that will not be available in TensorFlow. But if you are using a predefined well-known activation function, it will be available. Okay, now this input shape, this is the shape of the input layer. So as we have seen, right, this is the input layer, and the shape of the input layer and the shape of the data set, the one data point has to be same. Okay, so we have written here shape of the input layer, and in this case it has to be 784. Okay, because you have transformed the data in that particular manner. You have done the transformation of here you have already transformed the data by reshaping it. Okay, by reshaping you have converted into 784 by 784. Oh, sorry, 28 by 28 into 784. Okay, so why I have put 512? You can put less. Like, let us start with 8. Let me have 8 only. So now this model dot summary. Okay, so what is the total number of parameters is 6280. Trainable parameters are 6280. This include the weight and the biases. Okay, this the model dot summary will be showing you the summary of the layers. Right? If you will add one more layer, it will be shown in the next line. Okay, and now you again add this layer. I don't want to add it right now. Let us have less low performing model, and then we will accordingly adjust and make a better performing model. So, and now we at the end, let us add 10 units of why do we need 10 units? Because the output layer, right, must have the number of categories, right? How many categories are there? There are 10 categories. So we use 10 neurons in the output layer. Okay, so let me run this first, and then let us have, this is the old model, don't worry about it, we're going to run again. So this 6370 parameters are there, trainable parameters, and we have got two layers, right? First one is the has 8 neurons, and the second one has 10 neurons. Why do we need 10 neurons in the last layer? Because number of categories is 10. And now a question comes, what is this softmax activation function? Anyone knows what is softmax? Okay, so it will be giving at the end of this will give you a number between 0 and 1, right? The output of these 10 neurons in the last layer will be numbers between 0 and 1, and the sum of all those numbers, all those fractions, you can say the numbers between 0 and 1, all those numbers is going to be 1, and the number and the neuron from where we are getting the highest value, that has to be, that is the category to which our our data point belongs to. Okay, so that is why we use softmax for the final layer. Okay, now there are multiple ways of finding loss. One of them is categorical cross entropy, and there is something called binary cross entropy. Why? Okay, so categorical cross entropy we use because we have a categorical data set. The output values are categorical, and we have chosen our metric to be accuracy. So we will judge the performance of the model on the basis of how much accurate it is. So after this we have compiled the model. Now we are going to train the model, right? So this is important. So let me write it here, and I will also explain this, right? So fit, it means to, this is for curve fitting, right, basically, or for starting the learning, right? So X train and Y train are self-explanatory. Epochs, it is one go through the whole data set, right? In this case we have X train. When the whole X train goes to the neural network, it is one epoch. Okay, so epoch I should write. So this time we are going to do this process 5 times, right? 5 epochs we have chosen. Verbose equal to 1. This is for getting outputs while training. Okay. Now validation data. What is this validation data and why we need to use it here? Right? Validation data is after every epoch we are going to validate our model, which means after every completion of the syllabus you are going to test the student, and if the student is not performing well you will teach again. Similarly here, after you run one epoch you are going to test on some other data, which is the validation data, and then you are going to find out what is the accuracy of our model. If the accuracy is sufficiently good, that if it satisfies you, you stop more training. If it is accuracy is very low and you are not satisfied with the accuracy, then you are going to go for more epochs, or you can do some hyperparameter tuning. Okay, so let me start fitting it. Okay, so you see here, uh, let me copy this output and then I will put it in Sublime Text and then I will choose it. And I will discuss this finding. So we have trade for 5 epochs, and this is the output we have. Is it visible now? It is visible, right? Okay. Yes. Okay. So first question that needs to be answered is, why do we have this 1875? What is this 1875? This is clear that this is epoch number 1 of 5 epochs. What is this 1875?
Number of batches.
Hmm? Anyone would like to answer? Mm-hmm. Batch size? No, that is not batch size. Related to batch, that is not batch size. This is the, let me write it here. This is the, you are correct, it is related to batch size. It is not batch size, it is number of batches. Okay. So default batch size is 32. You can specify your own batch size if you want, using another parameter called batch size. Okay. So default batch size is 32. So 60,000 divided by 32 is 1875, right? Now what is the importance of batch size? Is another question. What do you think? Why do we need batch size, and what is this batch size? So batch size is, so everyone knows that we are doing back propagation, right? Back propagation algorithm runs after forward propagation, right? So you have got two things: forward pass and back propagation. Okay. So what happens is, back propagation is compute intensive. What it means is that it will take a lot of computing resources, lot of CPU cycles, right? Because a lot of math is going to be done when you are doing back propagation. So everyone, you know about back propagation, right? So a lot of math is to be done, right? So you have to do this thing, and you have to apply this chain rule for all the neurons, right? If the number of neurons is in millions, then it will take too much time. So all these calculations need to be done, right? And then what has to be done, and then the weight is to be updated, right? Okay. So what you, so this will, so back one thing, what we decide is, we put batch, we put a batch into the neural network, and then compute the loss, okay? After computing loss, okay, and then we compute the loss for the whole batch, right? And once we are done with that, we, when we compute the loss for the whole batch, we do back propagation based on that loss. Is it clear? So this helps us to have lesser number, uh, lesser number of, in short, I am writing back propagation, right? BP. Lesser number of BP passes, which saves time and also better for generalization. Why is it better for generalization? Because the contribution of one particular data point is less, right? You are finding the loss for the whole batch, which is for default for 32 inputs data points, and then calculating uh, the loss and then doing the back propagation based on that value of loss that you have got. Okay, so this was about the batch thing. Now, so you have loss. So this loss is, I'm not going to discuss the details of how loss is calculated. So while there are multiple MSE or MA, there are multiple ways of calculating loss. So for now, let us have let us take it for granted that the loss is being calculated somehow, and this loss is some value, and then accuracy we are getting. This accuracy is the training loss and training accuracy, right? And when we have validation loss and validation accuracy, what does it mean? So this thing, loss and accuracy is for the training data. Right? So based on this loss, this back propagation is going on, right? When you talk about validation loss, this is the actual measure of how the model performs on new data. New data here is what? The the X valid and Y valid um, arrays, right? So validation loss is less here, and training loss is more. Training accuracy is only 82%, and validation accuracy is higher, 89.6%. So this will give you a number between 0 and 1. You have to multiply it with 100 to get the accuracy in terms of percentage. So we see that we are able to achieve 92.89% accuracy after 5 epochs. Okay. So any questions on this?
What is the step here, sir?
Mm-hmm.
What is the step?
What is the step? Okay. This has taken 4 seconds, right? And 2 millisecond per step. For every batch, it has taken 2 milliseconds.
Difference between epoch and the step.
Epoch and
Step.
epoch versus
Step.
step.
Yes. Yes, sir.
Okay. So there are multiple steps that has to be done when we are inside one epoch, right? Multiple steps in one epoch. Okay.
Hello, say for example, you are having 8 lakhs training examples. All the 8 lakh training examples can be feed into the network in one iterate, one single step. So that 8 lakh has to be divided into number of steps.
Batches.
So batches means you take the entire data set. Training samples.
Wait. Can you say again?
So that steps like this, how much you are taking and how much you are updating the weights.
No, not that. That is not a steps here.
So processing of one batch of images is called one step, sir.
Yes.
So how many training samples you are taking, that is batch. How much you are feeding into
How
the
many
network.
training sample we are taking for one before we go do back propagation? That is batch. It can be done parallelly if you have a parallel system, or it can be done serially.
You have to specify step number, sir.
Mm-hmm.
So that the number of batches are equal to number of steps, sir.
Mm-hmm.
There 1875 batches are there.
Mm-hmm.
For that for 4 seconds and 2 milliseconds so per step. What it represent?
So we have 1875 batches, and it takes 2 milliseconds, right? So which is roughly equal to, which is like 3.7 seconds, right? So it has written 4 seconds. Here it is, right? 1000 seconds is 1000 milliseconds is 1 second. Okay.
So we are
And
updating the weight in step.
yes, after every step, that is for every batch, the weights are being updated. That is what back propagation is running after every batch.
So that means after every batch of processing the images, the back propagation is going to be performed.
Yes.
Yes.
So we
Then the
don't do
number
back propagation after every data point. We do back propagation after every batch.
After each back propagation steps, the weights are updated.
Yes. The weights are
That
updated
back
during back propagation.
weights are updated only in back propagation.
Yes.
That's the called as steps.
No, 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 no. No, there are two things, right? One is how much updation in weight, right? This is a step. No. Okay, this is not what this step is. This is not what this step is. Right? This is uh, steps here is when one batch has passed. Okay, so what happens is it divides the data set into 1875 different parts, right, which are batches. Okay, so 32 images, 32 images, 32 images, like that it will go. And when you process 32 images, and when you and then you do the back propagation, then it is one step. Okay.
Please come again, sir.
Okay, just a minute. मेरा किसी सुबह 5 बजे चलेगा।
नहीं आप इंस्टाग्राम में फोन आएगा ना वैसे
ये सिस्टम बंद कर दीजिए।
हाँ आप वाला यूज़ कर रहे थे ये वाला यूज़ कर रहे ना
ये यूज़ कर
बाकी में
वाईफाई चलने दीजिए।
ना वो नहीं
Sir, the batch is 32. There are 60,000 training examples. Yes, sir. Right? 60,000 divided by 32. You will get 1875. Okay. That's what is given there.
Step. What is step?
Step here is when you process one batch. One batch, processing of one batch is one step.
Total data set is 60,000. One epoch means total will come.
Yes. All the 60,000 it is going for one time. That is one epoch.
Then step for
Step means 60,000 divided by batch size.
Okay.
Training samples divided by the batch size.
1875 will come. 1875 batch means 60,000
So
only.
let me write epoch
Start by a step.
versus batch versus step. Right? This is the confusion. Am I right?
No, please explain.
I am again explaining everything one by one. Right? So 60,000 data points processed by the neural network. Right? This means one epoch. Is it okay? In this example, 60,000 data points. Right? 32 data points processed by the neural network and loss calculated, back propagation done. This is one step, right? Is 32 data points. This is one step, and this 32 data points, this is one batch. Make sense?
One batch is equal to 32 images.
Yes, exactly. And one step is when you process that images, those one batch of images, calculate loss and then do back propagation. That is one step.
At that point, back propagation is being done.
Right. So there will be 1875 batches. That is 1875 steps. Okay. In one for this example.
187 times weight matrix is getting updated.
Exactly. Weights and biases both. Yeah, weight you can say.
Sorry for the interruption. You can carry on.
Okay, thank you, thank you. Okay, nice. So let us go ahead and suppose we are not happy with this 92% accuracy. Now what we can do is we can improve the accuracy, right? And they are called, that is called hyperparameter tuning. We want to we want you can say we want more accuracy. Okay, so what can we do is that let me create a new model. Okay, let me create a new model and let me model 2 is equal to sequential, right? And then I will add, I will mostly copy and paste code right now. This model 2 dot add dense units. I suppose I am increasing the number of neurons in the first layer, and then we can add one more layer. Okay, model 2, and then we can add the last layer, which is this has to be the last layer. The last layer must have 10 units. And activation function has to be softmax, right? And we will have to compile this also. Okay, so model 2. Okay, so model 2 dot summary, right? So now I have increased the number of parameters. Okay, now I will just fit it. I will just use this code. Model 2 dot fit. Let me increase the epoch to 50, right? And let me run this. This time it will take a bit more time, because why will it take more time? Because the number of parameters is high. Let us have a look at what is the accuracy. In the first go only we have reached like 94% accuracy, 96% accuracy.
Excuse me, sir.
Yes.
What will be the impact of choosing units in the next layer, in the hidden layer?
Okay. So what is units? It is the number of neurons that you choose, right? If you see that the data set is bigger and your model is not able to learn properly what the data set says, then you want to increase the number of parameters, right? That is to say, when your model is underfitting, right, then you need to then you can increase the number of parameters. One way of increasing the number of parameters is to add layers. Another way of doing it to add more neurons in different layers, right? If you have too many neurons, right, then it is possible that the model is going to overfit. Overfitting means, okay, just a minute, I will show you the slide and we can discuss with that. Yeah, yeah. So bias is the error rate on training, right? And variance is how much worse it is as compared to the training error, right? So now underfitting is if the model is too vague, right? If there are, so you see in this straight line how many parameters are there? Only two parameters, right? And every particular, and one neuron is going to add more parameters. Every neuron is adding more parameters to it. So if there are too less number of parameters, so the model, it is possible that the model underfits, right? Which means that it is not even able to uh, represent the data that is available for training. And it is, if there are too many number of parameters and you do a training for a long number of time, a more number of epochs, then you are overtraining the data. Oh, sorry, overtraining the model with the data. So it is possible that the model is too much fitting the data. It is called overfitting. And when it is overfitting, any new data point comes, it will give more error for that new data point. Right? It is similar to say that if some student suppose has not studied anything for the examination, it is underfitting. Student who has learned the whole book, crammed the whole book, remembered everything, is overfitting if he cannot answer new questions. Right? And just right is when the student has actually understood how data is, and just right it means it is able to generalize better. Generalize better means when you are able to when the model is able to perform sufficiently well for new data points. Okay, so if you increase the number of neurons, you can move from underfitting to just right, right? Or if you increase the number of neurons too much, then it is possible that you may end up with overfitting. Does that answer your question, sir?
Yes, sir.
Okay, great. How many folks are done? Let us have a look. 15. Okay, so I will leave it like this. So 9948 98. So 98 99% accuracy we have reached, which is sufficiently good, right? So I am leaving this particular notebook run. Let us go to the next example that we have to take. Okay, which is the American Sign Language. I will share this also with you. So I am sending you on the same link, same email. Okay. Please also share this with all the participants. Okay, so we are discussing this. We have 20 minutes more. Okay. I will try to wrap up. Okay, I hope everyone has got this notebook. Okay. Now I have this data set here, right? Which is sign amnest, right? Related to amnest only. So, which is American Sign Language, right? Okay. First, we need to understand this ASL data set. We want to yeah. So this is it is something like this. Open image tab. I hope you can see this. So A, B, C, D, these A to Z, right? These are with hand gestures. This is for the people who cannot speak, right? Or who cannot hear. They are using this sign language. So what we have is a data set for this. Yeah, this is a good image to see. Right? So A B C D E F G H I J K J. This J is you need to move your hand for J, right? And then Z, you need to write Z with your hands. You need to move your hand with Z. Okay. So now the thing is, we have these images, right? And then we have to figure out. We have to make a model so that from this image we are able to find out what letter the person wants to say. Okay. So let us first look at the data set, how it is like. I have put this data set on my GitHub repository, and most of these code is also available on GitHub. I will give you the link, and I will give you my LinkedIn profile link also, through which you can connect to me. So this we have downloaded it. Right? There are two things, uh, two sheets, two CSV files that we need to download. We'll see what are they one by one. We need to import pandas and numpy for processing the data and understanding the data set. So this sign amnest train into training data frame, right? And then we have this label and pixel, right? So pixel 1, pixel 2 through pixel 784. What does this mean? Whenever you see 784, what does it mean? It means 28 by 28, right? So there are 28 by 28 images, and then it is flattened. The image is flattened into one particular array, and all the pixel values are available here. Okay. And label is 3, which is 0 0 is A, 1 means B, and like this 3. Okay. These are the labels, which means what? Which is the actual the category for that image. Okay. So similarly, we are going to read the validation set. Okay, same here. And then we are going to split the training DF into two parts. Let me write it. So what we need to do is, we want to split train DF into two parts, and they are train X and Y. Right? So we use, why do we need X and Y? X is the input, right, and Y is the output. Okay. So Y train and X train. So Y train will have the label column with it, and then we delete the label column from train DF, and then we get the values into the whatever the train DF is left with, we will take into X train. Makes sense? Right. So when you do values, it will convert the whatever data is there in the data frame into numpy nd array, right? And numpy nd array is used for the purpose of use in TensorFlow. Okay. This is a series only. Same thing you are going to do with validation part, x valid and y valid. So now we have four things: x train, y train, x valid and y valid. Okay. Let me first run this code and then I will explain it what it is. Okay. I'm plotting a figure of 40 by 40, right? And I'm taking 20 images for this, and for each image, for each image, for iterating from I is equal to 1 to 19, 0 to 19, for getting that first 20 images, the row will be the particular image, the flattened image, and the label will be the y value, and I'm going to reshape this particular row into 28 by 28, because it is, if it is flattened, if it is one dimensional, we cannot understand what image it is. We want to understand what image it, we need to do what? We need to reshape it into 28 by 28, right? So that we can see the rectangular or a square image, right? And now this is for plotting. Now we are plotting each image, right, in the color map of gray. Okay, so we have it like this. I'm increasing
Sir,
the,
instead of grayscale, we can bring it any scale.
can you say again?
Instead of the gray scale, C map equal to gray. Any color changes equal.
Yes, because this is a grayscale image, right? You can use orange also, so different intensity of oranges will be there. Okay, you can search different in different this so you can search like different C maps available in matplotlib type, and then you can accordingly choose whichever you want to use. Okay, so for grayscale images we are using, that is why we are using gray, because this image does not have color information and it is two dimensional only. Okay. So now again we are going to normalize x train and y x valid, same thing that we have done before, right? And then how do you find the number of classes? We'll just have a look at y train, what it is. 3, 12 to 22, I don't know, right? So it is a pandas series, and pandas has a function called unique, right? How many unique values are there in y train, right? There are these values are unique in y train. Okay, so now we are finding out the length of this array. This is the array of unique values in y train. Now this length of this array is 24, but there is one question: why 24? English letter has 26 alphabets, 26 letters in its alphabet. Okay, English has 26 letters. Why do we have 24? The reason behind that is that this J and this Z, and they for that you need to move your hand. The person needs to move the hand, so it cannot be captured in one image. Makes sense? These two cannot be captured into one image, J and Z. That is why we don't have those two images, those two classes here. Okay. So number of classes we have 24. Importing Keras. So this we have discussed why we need to do two categorical, one hot encoding, right? And then after one hot encoding we have this white train. Okay. Okay. So now we can make a sequential model. Right? So this is one. This is already I have made it, which works well. Gives you good. Okay, good accuracy, and then it is fitted for 10 epochs.
Yeah.
What is the accuracy we are getting? 54-55% now, which is very less. You know, 64%, not much, not happy with that. You see that training accuracy is 92%, while validation accuracy is only 70%. What is this? This is overfitting, right? It means the model is not able to generalize on new data. Hmm. So after 10 epochs, we have 95% training accuracy and only 65% validation accuracy. Right? Okay. So I want to add why did we have such I mean overfitting? We have more data, right? But we have less number of neurons. Let us try with increasing the number of neurons, right? I have added one more layer here. Again, it is fitted for the 10 epochs. It is getting better, right? Validation accuracy is also increasing now.
Since PPT will give you the
Okay, still we are not satisfied with the performance, right? Because the validation accuracy is like 79%, but the training accuracy is 96%. We need to try another way of doing it. we need to try with CNNs. So shall I go with convolutional neural networks, or do we have less time?
Sir?
Yes. Yes, please go ahead.
CNN. Okay.
I,
CNN theory tomorrow.
you want to, the time is about to get over. Shall we discuss CNN, or shall we not
Sir,
discuss CNN?
CNN I will discuss tomorrow, sir. CNN. No
Okay,
issue.
okay, great.
But share that notebook, sir.
I have shared it now. I have mailed you.
CNN notebook. Sir.
Yes, same. It is the same notebook. Here it is. Here, let's create CNN. Okay.
Okay.
It is a long
Okay.
notebook, so CNN is also here. If you need it, if you need me to want me to explain this, I can come for like 15-20 minutes any day. If you need, then we can discuss this also. Okay.
Tomorrow come at 9 o'clock, 9:30.
9:30.
9:30.
9:30 tomorrow. Okay.
Tomorrow I will take the CNN theory part and this.
And after theory part, I will do this. Okay.
Yes.
Okay. Great. We will we'll talk on WhatsApp or whatever. Thank you. I hope you enjoy the session. Acha, I would like to connect with all of you. So I want to share my LinkedIn profile with you so that you can find me out, and I can connect with good people. So this is my LinkedIn profile. Right, so you can contact me here. You can use this QR code. Okay.
அதான் எடுத்துட்டு
நான் அப்ப கிளம்பலாம்.
கிளம்பு.
ஏன்னா அவர் வீட்டுக்கு போகணும்.
Thank you, Prabhas sir.
Thank you very much.
Thank you very much for sharing your time with us. In future also we will continue to collaborate for other works.
Thank you very much.
Thank you, sir. Thank you. Bye.
Bye.